Okay. What are we doing on this problem? What's like the main goal here?
We're dividing.
Dividing. What type of division?
Long.
Long division. Okay. This is a type of problem we need to be comfortable with. Same as synthetic division. Now, why do we have to do long division on this problem? Does anyone happen to know? What? Okay. We're gonna have a big trouble trying to factor it. I agree. Number one, can't factor that thing apart. Number two, what's another reason? You were right there.
Okay, different number of returns.
Okay.
Is that not right?
You're onto something there. Like the concept what you said there is actually onto it. What we're dividing by, the divisor, the x squared, that's just, it's not a binomial, that's a trinomial. It's like it's bigger than just a single item. You have to do long division in that case. The only time you can do synthetic, if you're gonna choose to divide by a single number like that. Okay, that's the only time you can actually choose to do that. So keep that in mind. Now, what I'll show you later is like, you can change this problem to make it a synthetic in case you're like really stumped or you're not sure if you did it right. There's always a backup, how to check it. There's actually two ways to check it. But anyways, let's go through this problem just to remind you just how to do it, and then we'll get into the actual review today. But this is one of the problems we did yesterday and the day before. And I didn't want to leave off because we didn't really talk about how do you check to see if you're doing right. We didn't do that, bless you. All right, so what do we have to multiply on x squared to make x cubed? X, right? 1x, right? And that has to go down here. Has to be lined up with a letter that is that's the same like power, so it's above the x term. So when we multiply by an x, we have x cubed, 11x squared, and a 30x. That's positive 30x. Okay, makes sense? We multiplied everything by x's. All of these by x's. That's what I'm getting at. Now what do we have to do?
Switch the signs.
Switch the signs because we're actually subtracting, right? So we're going to subtract straight down. So we're going to subtract, and go straight down. That makes 0. This makes negative 3x squared. This makes negative 33x. And we have the minus 90. Because we bring the next term on that. That's how long division works. Okay, now we start all the way over again. So we're back to the beginning. What do we have to multiply on an x squared to make a negative 3x squared? Negative 3. Okay. So negative 3. So when we multiply that, negative 3 times this is negative 3x squared. Negative 3 times this is negative 33x. And negative 3 times that is negative 90. We switch the signs, just like we did the last time. So switch the signs, go ahead and get a big old loose egg here. And so it actually does work. So it actually did have a perfect remainder of 0. If that was like, let's say like you were left with like an x, and there's nothing else left to drop, then the trick is, what you do is whatever this remainder is, whatever it is, so in my case mine's a 0, you can put it up here on top of the fraction. This is how you get mixed numbers, by the way, when you do long division with numbers. You take whatever the remainder is, you put it over top of what you divided by. So x squared plus 11x plus 30. That's actually how you get mixed numbers, and you just add the fraction up. That's what the answer is if there's a remainder. Well, I have 0, so I don't really need to have that. 0 divided by anything is still 0. All right, questions at all about how to do that problem? So it looks like x minus 3 was a root. That was one of my x-intercepts. The other two were made from the thing I divided by, so it actually worked out perfectly that it divided out to be 0. Now, there was one way to double check to see if you did this right. Actually, two ways. Number one way, if you divided it and you got to 0, you're probably doing something right, just saying. If it turned out to be a weird thing left over, you're not doing it wrong. But there's a way to check it. What you do is you take what you divided by. And this is something that you should be able to do because we did this in the previous chapters. You take what you divided by and you multiply by what your answer was, right? The x minus 3, like what your quotient was. And if you multiply those together, you'll get back to the thing that's inside the house, the dividend. So that's how you know, like, if you're doing it right and you actually multiply them, it should get back to what you started with. So it's the opposite of dividing, you multiply back. Okay? That's one check. Some people really like that. The other way to do this is to break up the outside term. If you can factor this apart, because usually the outside term is small, can that thing be factored apart? Yeah, what is it?
5 and 6.
5 and 6, okay. So x plus 5, x plus 6. Okay, we have that. And so the idea is that So this number represents -5, this number represents -6. And what you can do is you can synthetic divide each of those out one at a time. So if I wanna do synthetic division, put a -5 here in the house, cause that's the number that represents -5, put that whole thing over there, that's 1x cubed, 8x squared, -3x, -90. Divide each of these numbers out one at a time. You can do it that way. That way you can kind of bypass the whole long division idea and still get the same answer. I'll still get the x minus 3 in the end. So, but you have to do whatever this is, so this drops down to be 1, multiplied by the number, drops straight down, multiplied by the number, drop straight down, multiply by the number, and drop straight down. Okay, there we go. What we're left here, if this thing is actually factorable, you could keep going. You could like factor that apart and see, to see what the other parts are. If it's not factorable, just take your other number that you had, the -6, and divide what's left. The 1x squared, 3x, and -18. And you can just do this again, and what should be left over, I know this seems really goofy doing this. 18 turns out to be 0. This is a 1x minus 3. Like, it turns out to be the thing that you're left with. Because I divided the 5 out, and then divide the 6 next. That's another way you can do that problem. I didn't really talk about that yesterday. I want to just discuss. All right, questions at all about what we're doing? Okay, we're doing long division, just kind of remind you. Okay, the last thing, other than, you know, how to check your answer, synthetic division. I think, gotta go mark your present now. Gotta go mark your present, so. Okay. So, what we're gonna do next is to check, you know, what type of roots this problem should have had in the first place, the original problem. That's what we did yesterday. Now, we already know all the roots to this problem. We already factored them up. We already talked about it. One of the roots is this, that represents +3. One of the roots was x plus 5 and x plus 6, and we factored those apart. These are the x-intercepts for this problem. So there's a lot of negatives. Well, when we do that rule, the Descartes rule sign that we did yesterday, that process should clarify that on this problem. So this problem is x cubed plus 8x squared plus minus 3x minus 90. Okay, so doing Descartes rule of sign, you count how many times the sign switched in this chart. So again, this chart is positive numbers, negatives, and imaginaries, because it might have imaginary roots because maybe it doesn't hit the x-axis. And what should each row add to be? 3, because it should always add to be the biggest power. Okay, you shouldn't have more than 3 roots in this problem. But again, what you do is you start at the beginning, you do little bunny leaps, and you count how many times did it switch signs. So if I count, that was positive, stayed positive, that's 0 still. Switch to negative, so that's 1 switch, and it stayed negative. So it has 1 switch. Then what you do is if you can, let's say this is a really big number, you can go down by 2s every time. So if that was like a 7, it'd be 5, 3, and 1. You subtract 2 every time. But I can't subtract off of that. So there's only 1 row. There's 1 option for how many roots there are. 1 number is positive. In fact, we already know what it is. It's 3. Does that make sense? For negatives, you plug in negative x's into everything. Right? You plug in negative x's into everything and you simplify it. And then you do the same thing where you count how many sign switches there are after you simplify using common sense. So actually, simplifying this will stay negative because it's x to the 3rd. This will cancel out the negative signs, so it'll be 8x squared. This will be a positive 3x, and that'll be a negative 90. So if I count now, notice simplified everything, it was negative, switch to positive, stayed positive, switch to negative, so there should be 2 negatives. Again, you'd have to go down by 2s, but since there's no other row down here, I don't need to have that one. So I'll show you kind of the other option, but this should be the option that we have. You should have 1 positive, 2 negatives, and 0 imaginaries. Now, what I just hinted at a little bit ago you know how I told you can go down by twos, right? There is a second option, and I didn't tell you this yesterday because we're always finding problems that have nice roots to them. But the other option is that what you do is you carry the one down, like you carry this down, this is not normal, but you carry the one down, and when you add up, there could be two imaginaries on this problem, potentially. Because you could have the zero for the negatives, the zero negative numbers would work, and then you'd have two imaginaries. Now, why I bring this up, and I didn't tell you this yesterday. The reason why I would do this is that if I was doing this problem, you know, and I saw this first chart, right, I would check negatives, because there's two of them, potentially, right? That's why I would go after those. That's the reason why we did the rational root theorem, to find roots. Like, this helps me just to guide me, like, I should go check the negatives. There's more of them. But there's also that other part of me that says, just knowing that there's this option here, that it is guaranteed that there's one positive number. So that's in the back of my mind, like, maybe I should not check the negative numbers, maybe I should go check the positive, because I'll find one no matter the condition. Does that make sense, like the rational thinking there? So, I didn't want to share that yesterday because I didn't want to, because some of the numbers you have have just worked out. But I want you to know how to do long division. I want you to understand what roots are, synthetic, what this Descartes rule of sign is. You gotta know how to do that. It's pretty easy. And that's the other reason why we plug in negatives. Like, this checks symmetry, but it also checks for how many roots you have. Okay, we're good today so far? Okay, let me hand out your practice guides. So the goal today was to go through a couple of examples of these. So my goal is to get in the first 4 today. So there's 2 there. Let me know if you don't have a front and a back and a front. There should be 3 faces, but printers sometimes don't work. I had one, was it weird having to do where it didn't have the front and back in front, but they were still stapled. It was really weird. So I'm gonna print a load and check that over. They should be on the back. Oh, sorry. I'll pop it up here in the projector and we'll get started here. Okay, this is exactly basically what your test looks like. It's gonna be, what is that, 7 questions, something like that? 7 questions? 9, sorry, 9 questions. So hopefully that is less stressful for you, that you know it's just 9. It's pretty basic. It's going over everything we talked about. You can use graphing. Graphing functions, we'll talk about that here in the beginning. Oh yeah, there's. Okay. Look at your first problem. Is that? Is this your first problem that you guys have?
Yeah.
Okay, good. I have 2 different versions of this thing, so I gotta make sure that this is the graph you got. Alright, now I gotta warn you, not on this first one, but on the second one, you will have to change the scale of your graph, the one that I provided you, right? So maybe off to the side you can label, because like, if you notice those graphs go to like the 16s and 20s. So in your graph, on that number 2, we will change that. We'll scale it up so that it makes it work. Does that make sense? So we'll try to draw a picture and we can see how that's gonna work. So first thing, we're doing transformations. The goal is to go through these so you know what to do. I basically want to just talk you through it. The outline for the order of drawing will be on the board on test day. So here's the order. I'm gonna put it up here right now. Number 1, you do a horizontal shift, if you have it. And again, this will be on the back board during the test days. Number 2, then you're gonna do a stretch or shrink. And that goes for vertical and horizontal. You do just one after another. And I'll kind of show you what I mean by that. And know the rules, especially in shrinking. Shrinking vertically is when you put a fraction out front of the f. out here. And on the inside, to shrink it, you put a whole number. So like a 2x in here. That will shrink it horizontally. I know that seems really backwards, but 3 is a reflection. That's where you flip things over the x-axis or y-axis, depending on what sign happens here. That actually happens here. Number 1, we do have a reflection. And number 4, you do some type of rotation or rotation stuff, but it's also for us it's a vertical shift. Those are the ones I'm going to be testing on. I'm not going to test you on rotational stuff because we didn't talk about it in class. Those weren't difficult. Okay, let's talk about your problem number 1. Okay, I already talked about that. We do have a reflection on that one. Anyone happen to know what type of a reflection we're going to have with this negative sign? In which direction? Does it go x-axis or y-axis? X. It goes over the x. So all these numbers, the first step you should be doing, all of these dots right here, here, and here, they basically flip over the x-axis. Only 2 of them will stay. So that's what the negative sign out front means. So what I mean by that is these dots right on the x-axis will stay there. This dot will go to the other side. This dot will go to the other side. Does that make sense with that reflection? That's when the negative is on the outside. If the negative was on the inside, it would go across the y-axis. So this dot would have stayed there, but all the other 3 dots would have moved. Okay, does everyone understand how they're going to do that? And then just draw the picture. It's going to basically look upside down. Okay. Next, what does the +1 mean? Right, left, up, down. Which one?
Right.
It's up. How I know it's up? It's on the outside. So outside the parentheses going up. So this is up 1. So you got to flip this thing over and then you go up. So this thing should look something maybe like this, but it's going up 1. So it might look more like such. Does that make sense? Like what yours is going to look like? Mine is not drawn to scale, by the way. I'm just doing it really quick. So it's flipped over, and then it's moved up 1 from those dots. Sorry, it's not drawn perfectly to scale. I'm just trying to give you a rough guess what you're doing. Okay, all those things were from section 1.6. So if you need to go back to section 1.6 in your textbook, they have a really nice chart on those pages where you can see like what are all the different rules, how do you do them, what does it look like. Okay, we're good with that? Can I move on to number 2? Okay, now number 2 is the one I warned you of. We're going to have to change the scale on this one. So, alright, so number 2. Alright, so for number 2, we're going to be definitely stretching this thing, so we're not reflecting. We don't have a negative sign on the outside or in front of the x, so we're not reflecting, but we are stretching this thing. It's actually going vertical. How I know it's stretching vertical is because of this number right here. It's on the outside, so that's a vertical number. If it's on the inside, that's horizontal, but this is a stretch, so it is getting 6 times taller, but the x-axis numbers stay the same. So like this, this number here will stay 0, this dot will stay 0, but everything else goes 6 times higher or lower to where it is now. Does that make sense? So if it hits the x-axis, if it has an x-intercept, those will stay where they're at, because those are technically zeros, and if you take 6 times 0, it stays 0. But everything else goes 6 times taller. So, what is 6 times 12? What's 6 times 12?
72.
Boom, you're 72 dot. This dot is at 72 up in the air now. So you got to change your scale. You can go by tens, I don't know, so you can make it work. This number, this is 16. Now I got to go times 6. So that's going to be way up there. What is that, 96 or something like that? Geez, that's way up there. So maybe you have to jump by tens on this graph, just so it can fit. But it's still going to kind of look the same, right? It's still going to look kind of like this, but it's just now really tall. Just really tall. And the numbers off to the side, like you actually say, like, this is 90, this is and 7, 8, you know, you just change the scale. Okay, but the next thing is that what you have to think about is now that, you know, I stretch, I always try to talk about stretching and stuff. We do have to move it horizontally though. The reason why, they did throw a number inside. Does everyone see that? It's not on the outside, it's on the inside of the parenthesis. Where is that thing going? It is moving horizontally. Right or left? It's going to the right. So all these dots are going to move over 2. So this dot will move over 2 from where it's at right now. It'll be here. This dot will move over 2. So 1, 2, so it's going to go here. This dot will move over 2. And so it's still going to kind of do the same thing. It's still going to do the same thing, but all the dots have been moved over 2, and then you're going to make it 6 times taller from where it's at. So these X-intercepts will stay where they're at, because everything else has been stretched. Okay, does everyone understand why it's moved to the right? 2, it's got -2 on the inside. Everything that's on the inside is always the opposite of what you think it does. So if it's minus, it goes to the right. If it's a whole number on the inside, it actually shrinks horizontally. Okay, I'm picking 2 at random that were probably in your homework. So this is just to get you an idea of like the level that I'm going to give you. I'll give you things where you do 2 things to it. Possibly 3, but they're not going to be like overly difficult. Okay, questions at all? Alright, scroll down. I don't know what time we got here.
56.
56? Okay. I don't know the chart since we have this assembly today. I gotta get that pulled up here. Alright, number 7. What we have to do first, we're supposed to graph this thing using that 7-step process. Figure out, you know, end behavior, leading coefficient test, X-intercepts, Y-intercepts, all that good stuff. We do have to FOIL this thing out. Because it doesn't look like a polynomial. Do you agree? It's kind of weird looking. We do have to FOIL it out, make it look like a polynomial, then we can do all the little shortcut stuff and figure out where this thing is going. I even give you a graph off to the side so you can draw it, kind of a rough sketch. And again, these problems, I'm looking for a rough sketch where it's going. You should be drawing the tails, you should be putting X-intercepts roughly where they're at if you can find at least one. Figure out where the Y-intercept is. That's really all I need. You know, the bumps and valleys, it's whatever you think that it does. Okay, but we need to FOIL this one out. So I'll do this one for you. The next one's already ready to go. That is problem number 4, right? It already looks like a polynomial, correct? I tried to pick easy ones. I wasn't picking like crazy big things that you can't possibly even do. Because if you can't find the X-intercepts, thanks. You should be able to do the quadratic formula on this one, and it should still work. Does that make sense? Because I tried to pick like a quadratic. So, alright, but if I FOIL this out, here's what I get. I get x squared minus 6x plus 9. I have to add the 2 because that was on the outside. How I got this, I FOILed these 2 parentheses out. There's actually 2 parentheses. I FOILed them out. That's how I got that thing. So it's actually x squared minus 6x plus 11. Okay, so this is my polynomial. This is what I'm drawing. What does it mean when it's the power of 2? Where are the tails going? Same direction. They're going up. For me, it's positive, so my tails are going to eventually finish up here. Okay, I don't know where my X-intercepts are yet. What's my Y-intercept? 11. So it's up in the air. This thing's way up here. Okay, so we're way up here for a Y-intercept, so my drawing is not super accurate right now. Okay, so we have that. Let's figure out X-intercepts. Well, I can't factor that apart. I can't factor out 11, so I'm going to do the quadratic formula. I tried to give you that, so you know. I will have the quadratic formula on the board. It'll be on the back board, so you know it. But that's negative b plus or minus square root b squared minus 4 times a times c. And yes, I realized I didn't put a negative because I'm squaring it. I know it's going to turn positive, and yes, this is the opposite of negative, so. And this is all over 2 times a. So this turns out to be 36 minus 44. So right here, what am I going to get on the inside? Negative. There's no X-intercepts. So that means it's up in the air. So really all I have to do on this problem is do this. That's roughly what I think it's going to do. It's going to turn once in midair. It hit my Y-intercept. I don't even know where it's turning. That's all I expect to see. Like a rough sketch. Does that make sense? I will try to pick a problem for you that maybe there's X-intercepts, so, and maybe you can factor. I just wanna see, do you know the basics? Do you know where the tests go? Do you understand if it's positive or negative where they go? That type of thing. Or can you do quadratic form? I don't know, please figure it out. Okay, you can do number 4 by yourself. I always try to pick out 2. That one should be a lot easier than this one. But again, even if I pick a third power, I'm gonna probably pick one that's factorable. Because you have to at least be able to find a couple things to do on that one. All right, so that's it for today. I just want to go through the first 4. The basic stuff. Transformations, graphing polynomials. The next problems on there we're gonna do on Monday. Test is tentatively set for Tuesday. Unless something were to happen, but that's where I have it set right now. Same exact number of questions, same order, they'll have the same general pattern, same general questions to them. Okay? So your goal today, if you can, try to finish up 1 through 4 today at some point. That way Monday, if you have questions, you can ask those right at the beginning of class, because we'll have a full class on Monday. And then we'll go through and we'll finish, 5 through 9 on Monday. Okay. Any questions before, the bell goes off here? Perfect. Okay, good. I'll update today's website so you can watch this video if you need to, if you didn't quite get something.